Welcome back for this class. This is our third class for the vectors we have studied previously. During the previous classes, some of the vectors concept, definitions, types, addition of the vectors. Now we are heading towards the next topic of the vector, that is product of two vectors. How to take product of two vectors. Multiplication can be done in two ways. Number one is scalar product. Number two is vector product. Concept of a scalar product is that when two vectors are multiplied and the resultant is a scalar quantity, the product is called scalar product. What is the example of scalar product? Suppose you are given force. This is a vector, and when you apply a force on any object, it covers some displacement. Displacement is also a vector. When you multiply these two, you are getting a scalar quantity. That is work done. So there is a dot written between the two quantities. Scalar product is also called dot product. When it is obtained, when we multiply the two vectors, when we take the product of the two vectors, and we get another quantity which is a scalar, this type of product is called scalar product. Here it is. If here is a vector A and the other one is vector B, we are taking the dot product of these two vectors. This is the dot product. You write AB, that is cos theta. Angle between two is cos theta. There is a strong logic behind this reason why we write cos theta is force, the physical concept. When we calculate the work done, we multiply force with the displacement. And when we see the physical concept of the maximum minimum work, it is only applicable when we write the cosine theta between the two. So that's why cos theta is used in the case of dot product. That represents dot product, we put a dot between the two vectors. Therefore, it is called dot product. Here it is. And the next one is a vector product. When we we have discussed. When two vectors are multiplied, the resultant obtained is a vector. The product two vector is called cross product, or it is also called dot product. Sorry, cross product. When two vector quantities, suppose you multiply force with the moment arm, F multiplied by R, you are getting torque. Torque may be clockwise, anti-clockwise. This is basically vector quantity obtained. So this is the concept of vector product. When we multiply two quantities together, two vectors together, and as a result we get another vector quantity. This type of product is called vector product. What is the example? The example is torque. So here it is. When two vectors are multiplied and the resultant obtained is a vector, the product two vector is called vector product. That's the explanation. To represent this type of vector product, we put cross between the two quantities, when between two vectors. Therefore, it is also called product of two vectors. Suppose A cross B. It is written as AB and sine theta n. This n shows the direction of the product. Basically, if there is x, this one is, if you look at, if this one is a vector A and the other one is a vector B, this vector is a B, and if you are rotating, you use your right hand. If you are moving or taking the product of A dot B, or you are moving it along from A to B, so you are taking product A cross B, and your finger will show the direction of motion of rotation of vector A in the direction of B. Your thumb will show the direction of the product, and along your thumb there will be a unit vector n which will show the direction of the product. So here it is, this one. If your right hand rule, curl your finger in the direction of A to B, then thumb points in the direction of product of these two, and thumb is along thumb. This will be the unit vector which will show along which direction you are rotating the body, A to B or B to A. Similarly, it will be the case If you're trying to move it from B to A, your thumb will be inward or opposite to N. So that's why A cross B is equal to minus B cross A. This is the concept of multiplication of the vectors, taking the cross product. Cross product, this is the property of the cross product. Look, A, B. So B, here it is a vector B, here it is a vector A. So this is the component of vector, horizontal component of vector. So this is the component of the vector along x-axis, and this is the component of vector along, again, this is the vertical component of this vector. And if you multiply a vector with the other vector, this is the basically component of vector B along that vector. So here it is. These are some of the examples when we are getting vector product, and this is an example of dhar. This is example of angular velocity. This is basically calculated angular velocity, and this is angular momentum. That is the example of a cross product or vector product, and this angle shows the direction of the product. This shows the direction of the product. When you're taking A cross B, that is AB sine theta, and if you're taking B cross A, it means you're rotating from B to A, your thumb will move in opposite direction, so that's the negative sign. So here it is, we can prove A, B cross A, that is equal to minus A cross B, because with the change of the direction, the vector pointing along the direction of your thumb, which shows the product of the vector, it becomes opposite. So here it is, the next one. If you are taking the cross product, this is a triangle, sorry, this is a circular line, circular pattern. And you can understand this is the best technique to know when it will be, if you look at, this is basically X, this one is Y, and this one is Z perpendicular to these two. If you look at, if you're rotating it from X to Y, your thumb will be along positive Z axis. So along Z axis, the unit vector will be K. So it means that when you are multiplying two vectors from X to Y, I to J, means this one is I and this one is J. That will be equal to K. And when you are multiplying J cross I, that will be equal to minus K, because you are rotating in opposite direction. K cross I, that is J. I cross J, if this is I, this one will be J, and this one will be K. So this means that I cross J, that is equal to K. J cross K, that is equal to I. K cross I, that will be equal to J. So if you follow the anti-clockwise, that is, if you follow the opposite to that, then the sign will be opposite. I cross K, that will be equal to minus A. This one. And K cross J, that will be equal to minus I. K cross J, that will be equal to minus I. So this is the concept of multiplying. Whenever you are multiplying I cross I, it means a unit vector I parallel to another unit vector I. The angle between the two will be sine 0, and it will be 0. You will be getting 0. But if you are taking the dot product, that is I cross I dot I unit vector I parallel to unit vector I, and cos of angle between the two, that is 0. Cos 0 is 1. So it means I square is always 1, J square is always 1, K square is always 1. But in case of I cross I, it will be 0, because sine 0 is 0. Because you write, in case of cross product, you write sine theta. And angle between K cross I, K mean one unit vector parallel to another unit vector. K cross I, K, that is 0. But in case of I cross J, it will be equal to K, the third one, this one. If you rotate in this direction, that is I cross K, that will be equal to I. J cross K will be equal to I. K cross I will be equal to J. So if you reverse the order, then it will be minus sign. So here are some of the examples to take the product to understand I, j, k, and it is also equal to three vectors. If you are multiplying the two, you will be getting the answer which one is the remaining. I cross I will be 0, j cross j will be 0, and k, and this one will be difference. In case of multiplication, you have explained here, if you are multiplying a plus a, the whole factors multiply by the b, then you will multiply axi with bxi, then you will multiply axi with byj, then you will multiply axi with bck. So the only factors remaining will be I and j. Yeah, when you will multiply with the same unit vector, it will become 0. So this is the simplest type of the technique to multiply. So if you are multiplying, you have written the brackets between the two. Here it is. You will multiply this I first one with this one, then you will multiply the same with the next one, this one, and then you will multiply with the third one. Then you will see if you are multiplying axi with by bxi, I cross I will be 0. Then the remaining one will be when you will multiply xi with byj, and when you will multiply xi with bzk. So here will be the remaining one. The rest, all the numbers are the will become 0 due to the fact that when you are multiplying, taking the product of I cross I, this factor will be 0. Then same will happen when you are multiplying Ayj with Byj, J cross J will be 0. Then the only remaining will be the 2 when you are multiplying with Ayj. And it will depend on the sign from where to where you are multiplying. There is another method to multiply and take the cross product, take the ijk unit vectors and then use the techniques to solve, which we have used to solve this one, the matrices. Same is the technique used in case of addition. These are the two vectors A and B. You are asked to first this is the task to complete A plus B. Then you are taking dot product, then you are taking cross product. These are three questions for this. So you have this is a type of assignment for you people to solve. When you are adding these two, I will be added with I, J will be added with J, and K will be added with K. So here it is. K, J component and X component or I component. K plus K is this one. If you're taking dot product, you know that I dot J, J dot K or I dot K, that will be 0. But what will be remaining? I dot I, this will be remaining in this case. This is total opposition case of cross product. 2 multiplied 2, that is 4. I square 1. So when there is I dot I, it will be 1. When there is I dot j, it will be 0. Why? Because when you are writing the angle between the two, cos 90 becomes 0. So that's why it is 0. But sin 90 is maximum. So I cross j, I cross k, that is a vector. So I dot I, j dot j, k dot k, one vector I, another vector I, and the angle between the two, that is cos theta. When cos angle is 0, you know this cos angle is 0. And cos 0 is basically 1. So that's why it becomes 1. Cos 0 is always 1. So that's why it is basically unit vector magnitude 1, 1, and cos 0, that is 1. And I dot I is equal to 1, j dot j is equal to 1. This is the reason. So if you are using 90-degree, cos 90 is 0, so that's why I dot j is 0. So here is the cross product. You have to take the cross product. This is the example how will you multiply. And when these are 0 and when they will become sine or any other third vector. So you know I cross I is 0, I cross j will be k, k cross I will be j, and j cross k cross j, that will be equal to minus. So here it is, when you are multiplying I with j, then I cross I, it will be 0. When you are multiplying with j, then it will be k after multiplication. So this is the concept of multiplication of two vectors. So here it is, and you will take the cross product and square of the cross product. Which of the following is not a vector quantity? This is form speed. If a vector is multiplied by a negative number, magnitude will increase by the same, but the direction will be opposite. What will be in case of positive? In case of positive, direction and magnitude direction will be the same, but the magnitude will increase by the same number. The correct representation of a vector in xy plane. Where is xy plane? Ax plus ay, axi plus ayj. This is the correct. Another magnitude of two vectors is magnitude of each force is F. Find angle between the two. So this will be the formula used. You will use this formula to find angle between the two. A dot B is equal to 0 across B. Then A and B are vectors. Another examples to take to understand what's the cross product equal to. With this, today's class ends. I thank you very much for your patience. Hope you people have understood today's topic.